Hi everyone, this is going to be the tutorial video for ballistics and tool marks this week. Um, be sure to check out the entire calendar that I sent you for the week because there's a lot of information, there's a lot of links in the calendar that go with this tutorial. Make sure you have already pulled up the guided notes that I have shared with you in that calendar. You've printed them out and you are either taking them as we go here or you've already gone through this tutorial once and completed the notes. If you don't have the notes completed at this point, please pause this and go through the tutorial on your own, filling out the notes, and then come back and watch this tutorial with your notes already filled out. Okay. The objective is that in this lesson, we're going to describe methods to analyze bullet and tool mark impressions. So we're going to start talking about tool marks. Now, up until this point, we've been kind of talking about bodies and stuff, but right now, we're talking about other parts of the crime scene. We're talking about doors, chain link fences, like whether or not somebody busted open a lock, walls, floors, these types of things. They can all have clues as to what happened at the crime scene, and it can help us figure it out. You use a crowbar, box cutters, saws, knives, wrenches, screwdrivers, pliers, chisels. These all have, to a trained CSI tech, these all have kind of unique characteristics that you can tell maybe what was used to do a certain thing at a crime scene. And so again, looking at every square inch of the crime scene and looking for the telltale markers of these types of things can help you hopefully get a conviction. We're going to start out talking about types of tool marks. The first type we're going to talk about is a slipped tool mark. It's one in which the tool slides or it's dragged. You've probably seen a car being keyed, but this could also mean that somebody did the same thing to a doorknob and you were trying to pry open the doorknob and you kind of missed and you slipped down it. That could provide a clue as to what opened it. You can also, like if somebody's picked a lock, sometimes that requires a lot of force and sometimes the lock kind of, the tools kind of drag along it and somebody can figure out that the lock has been picked. And that even to some degree, and we're going to get to this next, but we're bullet striations. If you have a bullet at a crime scene, you can do get a microscope and look at the the um, the grooves made on the bullet as it came out of the barrel, because the barrel has the winding that causes the rifling to go down it, whether it's a pistol or a rifle. That you won't find that in shotguns, but you will find that in pistols and rifles, and they leave usually a very identifiable slip tool mark. The next one is molded tool marks. This is when something makes a direct contact without any sideways motion. This would be things like a hammer. This leaves kind of a three-dimensional mold of the tool. Like, I don't know if you've ever driven a nail with a hammer into a board, but sometimes you miss, and that leaves a very clear indentation of what at least part of the tool looked like. This can be found in all kinds of things, especially in a human body. Things like like if somebody hits you in the head with something, you can tell by the indentation left what, partially to some degree, what shape it was. Bite marks and shoe prints are also molded marks because they leave a clear indentation of the teeth pattern, for example, or the pattern of the shoe. Many tool marks are a combination of slipped and molded impressions. A crowbar prying a door open, for example, can leave the mold of the toolbar and also the slip of the toolbar. So like all the other evidence, tool marks have two characteristics, class and individual. So let's take a look at these. Class is going to be what group, what type of tool caused it. Was it a metal tool? Was it a wooden tool? Was it, how big was it? Was it large or small? Was it generally shaped like something that can stab, or was it more blunt? Um, Investigators can identify the hammer, the size of the hammer, and even how it was used. Did they pound with it or did they pry with it? And they don't lead to an individual person, for example, but it does narrow down what they should keep looking for. We're looking for a hammer. We're looking for a screwdriver. We're looking for a 2x4 that may have some tissue on it because that's what was hit. this person was hit in the back of the head with, for example. Individual characteristics, these are things that can lead to a specific tool. These are things that are, they're like a fingerprint almost. They're unique to the tool. Striations or irregularities in the hammer. I know that I looked at the tip of my hammer just a second ago, and sure enough, I guess I've hit something metal with it, and it's left a kind of a groove on one part. And if I'll bet you, if I were to hit a piece of wood, you could look at that piece of wood and see the groove. And if you could find that hammer, then you can match that groove in the imprint to the hammer and go, this was the hammer that did it, and take fingerprints off of it. The fingerprints lead to me. You've gotten somewhere. So this is why these things are things to look for, because they can lead you back to an individual. So how do they do it? Well, there's a few steps. To look for tool marks, they identify a tool mark as evidence. So like, okay, we've got a mark here that we think is important, and we think it was caused by a tool. They then describe and measure the tool mark. They take photographs at all angles, just to make sure they've got a permanent record. They collect the evidence. If it's not possible to actually pick up, like if it were a piece of 2x4 or something, if it's not possible to pick that up and put it into a bag, then they can make a cast. So they pour some molding material like plaster of Paris over it, and they get a cast of the actual mold. Let that dry, and then um, uh, they can take that with them. You can get something called polymeric dental paste today, which is way better than plaster of Paris, and it cures very quickly, and it makes a very high resolution mold. Um, I don't know if you've been to a dentist where they make you chew on that. It looks like a huge wad of chewing gum, and you bite down on it, and you hold it for a little while, and then when you take it loose, they've got an impression of your teeth. Well, they can do that same kind of stuff to these molds on at crime scenes. After completing these steps, they usually talk about the class characteristics of the tool, the individual characteristics. They try to see if they can come up with something unique. They collect uh, they collect. Hopefully, they can find the tool then, and then they either collect it or they take photographs of it or both. They then make a comparison to the tool mark and the suspected object. And if you find that there are uh, there's a comparison, then you're able to then connect the two. This may involve things like a comparison microscope, which lets you put two pictures together. Um, if they match, then we know that it's evidence, and the evidence linkage is established. And you got to have this to be able to show it to a jury. You got to be able to say, look, we found um, this indentation here, and it matches with this tool, which then we can match to the suspect, and you have to show all that to a jury. You can't just say, yeah, he hit him with that hammer. You have to show a linkage between all of these pieces of evidence. Of course, one of the most important pieces of evidence that we can collect at a crime scene, if it involves a firearm, are things like the bullet casing, the weapon itself. Each one of these can give an investigator a very unique connection, a link. Imagine a crime is committed by a person going to a crime scene and shooting a gun, which discharges a bullet out the end at high speed, and it also discharges some gas and some other solids like pieces of the wadding, if that's there. It could also discharge pieces, small amounts of burned um, gunpowder. Then there is the casing that can be ejected depending on the weapon. It can be ejected at the scene, and then there's the gun itself. So you've got 3 or 4 different things here, and the only thing that's going to have a fingerprint or some type of a serial number is going to be the weapon itself. But if you can connect a casing to the gun, or if you can connect a bullet to the gun, then you've got more evidence. So this is what ballistics is. Another thing is that when a bullet hits something, as the bullet leaves the barrel, there are specific twists and windings. I'll show it to you on the next picture. There's specific twists and windings, and these windings right here, they're not straight lines. They actually twist and curve. They're designed to make the bullet spin, which gives it what we call a high ballistic coefficient. I think that's what it's called. ballistic stability. So as a gun, it's part of the engineering of the gun, but they can become unique. Each individual gun can have very unique a barrel twist, and so that leaves grooves onto the round as it's coming out. Well, when that round hits some things, it can actually turn those grooves and onto the door or whatever it hit as well. So not only should you look for the bullet, but you could look for things that the bullet goes through, which gives you even more evidence. Okay, so bullets and cartridges, we have a couple of things. We have class characteristics, just like we did on the other types of the tools. Now we're talking about bullets. Class characteristics would be the number and the twists of lands and grooves. That's these things, the lands and the grooves. How many are there? That gives you an idea of what kind of gun. The width, the depth, the pitch of the gun barrel. That tells you more about what kind of gun it is, what gives you an idea of what you're looking for. The caliber obviously is a big deal. If you can figure out the caliber of the weapon, you can now narrow it down to a specific type of weapon. Remember, class characteristics are helping you look for a type of thing. In this case, it helps us to figure out what type of gun we're looking for. And you'd be amazed at how just by looking at the bullet, you can tell what kind of gun it was shot from. We're looking for an automatic pistol, or we're looking for a revolver, or we're looking for a rifle. These are things that can be determined just by looking at the bullet. Sometimes just by looking at where the bullet hit, or the bullet pattern. If there's several bullets, you can tell that if it was possibly an automatic or even uh, like a machine gun, which is technically, I should say, semi-automatic. Yeah. Now, individual characteristics involving ballistics are things like on an automatic weapon, there is the well, hold on, let me show you a picture of an automatic. I think that's the next slide. Yeah, see right here, this is the chamber, this is the barrel, and as the gun is fired, if you could see it in slow motion, and I think it would be helpful if I gave you guys a slow-mo video of a gun being fired. But there is a little kind of a finger here that grabs the shell as this top part, the slide, is working its way back. There's a little ejector that grabs a hold of part of the shell and pulls it back and flips it out. That leaves marks on the bullet, or the casing. That leaves marks on the casing that can be matched to this gun. Now that's for automatics and rifles. Okay, automatic rifles, semi-automatics. They're called semi-automatics. Let me just clear this up, because I say automatic, but I should say semi-automatic. A semi-automatic means that you don't have to do anything but pull the trigger. Pull the trigger and it automatically cycles itself. Now it's called semi-automatic because a machine gun is an automatic weapon. You just pull the trigger and hold it, and it's bang, 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 bang. This you have to pull the trigger each time a round comes in. So it's pull the trigger, bang, pull the trigger, bang, pull the trigger, bang. That's the difference between an automatic and a semi-automatic. So I've been saying automatic, and I should say semi-automatic. Please forgive me. But this semi-automatic pistol, when you pull the trigger, the explosion of the gases of the gunpowder forces the bullet down the barrel this way. But because of Newton's third law, every action has an equal and opposite reaction. This slide is engineered to take a lot of the recoil and let it go back this way. And as it does, it grabs that bullet and flings it out. There's another bullet coming up through here, where through the magazine clip. It's not really a clip, it's just a magazine. And as the slide hits the back and there's a spring that starts pulling it back forward, it pushes the next bullet into the chamber. And all of these, every time this gun touches this bullet, it leaves specific, measurable, sometimes even unique um, markings on the casing, and of course on the bullet itself. And so these are very identifiable. And those are called the individual characteristics. Okay. In fact, let's take a look at it. I've muted this. We're going to take, this is the Mythbusters, and you're going to see very slow, and I may look at this a couple of times, but I really think it's important that you see this. See, as the gun is fired, okay, you see the bullet coming out, and a lot of gas. There's also some solids in there too, little bitty pieces of gunpowder. But now this bullet is going this way very rapidly. Now watch this structure here on the gun. This is the slide, and it's going to start going back. And watch this right here. This is the ejector port. And as this sling goes back, it will fling out the casing. Okay, see it going back. This is a great video. See the solids coming out in the end. These solids are potentially, well, what happened? Those solids could potentially end up in a victim. Okay. Now, did you see? Let's go back just a touch. Whatever, Jamie. Did you see that the casing has now been ejected out of the ejector port? Okay. That's going to leave marks. So now there's lots of marks on that bullet that came out and on that casing that can match to this gun. Okay. And so that's a lot of what happens in ballistics. Those striations, as the bullet comes out the end. No, let's go back. Hold on. Time out. As the bullet goes out the end of the barrel, let's see if we can go back some more. There's the bullet. Here comes the bullet. Come on, bullet. Come back. Oop, maybe not. There we go. As the bullet came out the end of the barrel, it was put down a very tight barrel that had those twists in it, and now this bullet is spinning. But there's also on that bullet grooves caused by the barrel, and you can match that up, and those are called striations. The breech face mark is on the back side of the cartridge case as it ejects. The breech face mark leaves where the firing pin hits the primer. I should show you a picture of that. Yeah, I have to take some of that out. So this is the back of the casing of, this happens to be a 45 round. And in the middle, that's a little primer. It's like a really small explosive. It's like a little piece of metal with a little bit of, and what happens is when you pull the trigger, a pin hits that. It's called the firing pin. It hits it there. And that causes an overpressure in this small chamber, and blam, it explodes, causing all of the gunpowder in here to explode, pushing the bullet down through the barrel. This is called a center fire cartridge, and you can see that it leaves an imprint. That imprint can be unique to the weapon. Here's an example of what we call a rim fire. This would be a 22 round. I'm not sure if it's 22 long. I think it is. But in this case, there's no um, uh, primer. It's just a small little piece of the gun hits the edge, and it causes an overpressure in this entire chamber and causes it to explode. Each one of these, whether it's a center fire or a rim fire round, each one of these can create a very unique marking that can be identified actually down to the individual gun. So these are individual characteristics. And finally, as I've said, the extractor and ejector marks. These things are when as I showed you in the video, the little tooth that grabs the bullet and pulls it out can leave marks as well. Now, as you can tell, this man's hand or this person, sorry, their hand is in very close proximity to all of this vapor. This is the gaseous result of the explosion of the gunpowder, and it has very unique chemical properties that then do attach themselves to the skin. And for an amount of time, sometimes even hours after a gun can be fired, you can do a test on a person's skin to see if they've recently fired a gun. It's called gunshot residue. A couple of ways to collect it. The first is to swab. You literally just grab kind of like a cotton swab, but it's more unique than that. But you grab this swab and you use some solvents like acetone or ethanol or just distilled water, and you swab the entire hand. And then you can send that off to a lab. You can also do vacuum lifting. That would be like pulling stuff off of clothing. So you put a little filter disc over the end of the vacuum, and you just suck all over it, and then you got the filter disc. Hopefully if there is any gunshot residue, it was collected by the cloth or the disc, and then you send the cloth off for testing at a lab. And then finally, you can just take a piece of tape and you can do that over certain surfaces, such as skin or clothing. But there may be some other um, uh, surfaces that could have been in contact with a gun when it was being fired. You can take and lift that. It will hold the chemicals onto the glue of the tape, and then you can send that off to a forensics lab. But there's lots of ways that you can test a person's hand to see if they've fired a gun, how recently, and sometimes even how much of a gun they fired. So it's really interesting. Once it gets to the lab, you can do a couple of tests. There's the dermal nitrate test. It's also called the paraffin test, and it's got a chemical reaction that reacts with the sulfur in the gunpowder. The grease reagent test, pardon me, similar kind of thing. Um, it instead of using paraffin or something, it has something called ethyl enadiamine and sulfonyllic acid to the suspected area, and it'll turn a color. So if you've got like a piece of clothing or something and you add this to it, if it's been in close proximity to a fired gun, it will turn red. Then there's the SIM-EDX. It's superior to both. It's much more conclusive, and it can also see much smaller amounts of residue, and it detects stuff that's found only in, usually only in gunpowder, such as things like antimony, lead, and barium. And that gives an investigator, when they're presenting this to a jury, they can say that they ran this particular test, which is even um, more superior. A good defense lawyer can maybe argue with a dermal nitrate test or the grease reagent test, but the SIM-EDX is a very accurate test that's hard to argue with. So one thing that happened, and it started back in 1999, was the ATF, the Bureau of Alcohol, Tobacco, and Firearms, and now Bureau of Alcohol, Tobacco, Firearms, and Explosives, they started collecting data. And now guns that have been used in crimes sometimes find their way back into society. And so all the data that's collected on, say, the bullet and all the striations on the bullet or the casing or the gun itself, if you can, every time there's a crime committed, all of this data is uploaded. And so what's nice about it is that it gives an investigator an ability to say, maybe we don't know what gun this came from, but we do know that this exact same gun was used in that crime over there 2 weeks ago, 2 months ago, 2 years ago. And so now we can start looking at that crime and getting a lot more comparisons and saying the person that did this, we know a lot about. If we assume that there's the same person using the same gun, we can know a lot about it too. So the National Integrated Ballistics, whatever database, is very useful, and it's something that forensic CSI detectives use all the time. Um, and that's what this particular slide says. The firearms investigator then secures the actual evidence for physical comparison. When investigators know that a specific firearm has been used more than once, they have more evidence at their disposal. So the thing is they got to enter their data themselves, and so you have to be trained in using the NIBN. But a great tool for investigators to have when it comes time to, uh, well, there's that answer. When it comes time to start examining ballistics. Okay, you got a free answer there. And that's it. This is a pretty short tutorial. So get to work, get caught up, and make sure that you're watching the video that talks about the whole thing to do for the whole week for the calendar. All right, get to work.